so for point K, that's right here. So what number is it for X? So yep, down here is that 2, and then for Y, it's at what? 1. Yep, so that's going to match up to 2, 1. All right, L is over here, so if I go down to figure out where it's at X is, where is that? -3, and then what on Y? +4, yep, so -3, +4. All right, and then M is over here, so at the X, where is it? 3, and then the Y? Yep, -2. Okay, N is right in the middle, so where's that going to be? 0, 0. Yep, 0, 0. And then P is over here, so -2 and then -1. So those should be the ones flashed up. For plotting the points, because you're supposed to plot and label, so instead of having to label like the whole point, I'm just going to make these like A, B, C, D, so I can just label with the letter. So remember, the first number is the number it matches up to on the horizontal. The second number is what it matches up to on the vertical. Okay, phones away, guys. Pay attention. So for A, it's 3, -3. So you're on the horizontal, you're going to go to +3. And then down to -3 on the vertical. So it's going to be right here. So it's going to be point A. Point B is at 0, -5. So that means you're not going anywhere on horizontal, but you're going up and down. So you're going to go straight down to -5. That's going to be B. C is at -2, +2, so -2 on the horizontal and up to +2 on the vertical. C. And then D is -2, 0, so just to horizontal to -2 and then not up and down at all. So D. Okay, do you have any questions on any of that? Like how points work, anything? Okay, so this whole unit is just kind of like looking at patterns, making tables of values, understanding how like to plug in numbers and get answers. It's just kind of more like abstract, I guess, a little bit. It's getting us ready for our next unit, which is when we like do y equals mx plus b and slope and all of that. So this is like the the basics of that, okay? So your objective for this one is students will be able to graph different functions using a table. Sketch graphs of related variables. And identify common mistakes on a graph. What? Like an extra one? I don't know, you can look around. Okay, so for your vocabulary, you have an independent variable and a dependent variable, but I'm sure you guys are talking about in physics, if not now, very soon. So your independent variable is going to be your x usually, and then your dependent variable is going to be your y. So the one that is changing first is the x, that's what's getting plugged into the function that we're choosing, and then the y is going to depend on whatever you plug in, okay? So the independent variable is going to go along with inputs, and your dependent variable is going to go along with outputs. Like the numbers that are getting plugged in, and then what answers you're getting because of that. And then a relation is, you can think about the word like relationship. So a relation is just like a pairing of x values with y values. And there's a rule involved. So like a table of values where you're plugging in x's to a rule and getting y's, that would be a relation. Okay? All right, so the main thing that we're going to cover in this one is how to make a table of values, basically, to graph. So the reason why we're going to make sure that we cover this is because every single function type this year, we're going to learn how to do the shortcut. So like y equals mx plus b, we're going to learn how to graph it with like the slope and the y-intercept. But at the end of the day, everything can be graphed this way. So if you forget how to do it, you can always do this, okay? And then I'm going to highlight this point right here where it says make sure you choose points that make sense in the situation, because there are going to be some word problems. So if we were doing a word problem that we were talking about time, we wouldn't use negative numbers. If we were talking about like number of kids, we would use fractions. So just kind of being aware of what your values are standing for, okay? Cool, good? All right, so let's move to this next one. So we're going to graph a couple of functions. The first two are linear, meaning that they're y equals mx plus b form. They're going to make a straight line, okay? So the way that we're going to do this is we're going to make a table, an x, y table. And really, you can pick whatever x's you want to plug in. I use pretty much the same ones every single time. I use -2, -1, 0, 1, and 2. The reason why I use those ones is because it shows what's happening on both sides of the graph, negatives and positives, and they're small enough numbers, like around the center, that my y values probably aren't going to go off the graph. If I go any bigger, a lot of times what happens is the y's are too big. You can't plot the points, okay? So you're going to take your function rule right here, and you're going to like take turns replacing the x with those numbers. You might want a calculator, it makes it faster. So the x is going to get replaced by these. So -2x plus 1. So we're going to do y equals -2 times -2 plus 1. Y equals -2 times -1 plus 1. Then 0. Then 1, and then 2. So you're just replacing the x with the numbers that you pick, okay? And you can actually type this whole thing straight in the calculator and get an answer. So I would grab a calculator if I were you and practice doing that, so you're not having to do it all in your head and getting it wrong, or you're not having to do it all on paper. Yeah. So just throw it in. So -2 parentheses, -2 parentheses plus 1, and get an answer. Then do it again with -1. So what do we get when we plug in -2? 5, yep. Now what about -1? 3. 0. 1. And then 2. Is everybody clear where those are coming from? By figuring out what that equals. Okay?
Wait, are they always going to be -2?
You can technically pick whatever you want, but I always pick those, yeah. Okay, so now once you have all that, now these are the points that you're going to plot, your x comma y, okay? So -2, 5, that means on the horizontal it's going to be at -2, on the vertical it's going to be at +5. So you're going to go left to the -2, and then up to the +5. I know it's hard to see, just do your best. And then next one, negative 1, 3. So go left to the negative 1, and then up to the 3. 0, 1, you're staying in the center and just going up 1. 1, negative 1, you're going to the right 1 and then down 1. And then 2, negative 3 to the right 2, down to the 3. Okay, and then if you're wearing your ID around your neck like you should be, it's pretty handy for making straight lines. And make sure you put arrows on both ends because this is going to go on to infinity in both directions. We just happen to pick those 5 x's, but you can pick any x forever. Okay. And that's that. Make sense? So you guys are going to do this next one. We're going to use the same x's and y's. Not y's, same x's. But your rule is y equals 3x minus 4. So go and plug it into that one now. Okay, I'm going to just kind of start going. So you're going to do y equals 3 times negative 2 minus 4. What do you guys get for that? Negative 10. And 3 times negative 1 minus 4.
Negative 7.
7, yeah. And 3 times 0 minus 4. Negative 4. 3 times 1 minus 4. Yes, negative 1. And then 3 times 2 minus 4. 2. Yep. Okay, so plot those points. So you're going to plot negative 2, negative 10. So go to the left 2 and then all the way down to negative 10. Go down there. And then negative 1, negative 7. It'll be right there. Bless you. Okay, and then 0, negative 4, just go straight down to negative 4 from the center. And then 1, negative 1, over to the right 1, down 1. And then 2, 2, so to the right 2, up 2. So it'll look like that. Still arrows on both ends. Okay, any questions on that? So both of those are linear, meaning they make straight lines. You can tell because they're in y equals mx plus b form, okay? The next two we're going to do are not linear. They're called nonlinear. But you're still going to do the same thing. That's like why we're learning this, is because this can work for everything, okay? So for this one, we're going to use the same x's. We have y equals 2x squared. So you're going to do y equals 2 times negative 2 squared, 2 times negative 1 squared, 2 times 0 squared, 2 times 1 squared, and finally 2 times 2 squared. If you're not going to do this in your calculator and you're trying to do it in your head, order of operations, what goes first, multiplication or exponents? Exponents. So you need to make sure that you're doing the exponent before you multiply by the 2 in front, or it's going to get messed up. Okay? But I suggest just putting that whole thing in a calculator. Exactly how it's written. Okay, so go ahead and practice plugging that in. Okay, what do you guys get for the first one? 8, yep. Second one? 2. Next one? 0. Next one? 2. And next one? 8, yep. And we see why they're the same, right? Because a negative times negative, positive times positive will get the same answer. Okay. So anytime you have an x squared problem, it's going to basically be like this, where it's going to have the same shape. So first one, negative 2, 8. So go left 2, and I'll loop to 8. Right there. Then negative 1, 2. So left 1 up 2. Then 0, 0, right smack dab in the middle. Positive 1, 2. So going right 1, but still up to 2. And then 2, 8. Right there. So you're going to get this U-shaped graph, and we're going to like go way more into detail second semester into these types of graphs and stuff, but all you need to know is that like an x squared makes a U-shaped graph, okay? Good on that one? Okay, the next one's not the same, because yes, it has an exponent, but like this one has a 2 for the exponent, and it's the base that's changing. This one, the x is the exponent, so the exponent's going to be what's changing. Okay, so let's do that one. So it's y equals 2 to the power of x. So these numbers are going in for that exponent. So you're going to have to do y equals 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, and then 2 to the second. If you don't know where the exponent button is, this button looks like this. Not that one though. Huh? You would just go like a quarter of the way up a box. Yeah. Yeah, so you will get decimals for a couple of these. what do you get for negative 2? Yeah, 0.25. What about negative 1? 0.5. What about 0? 1. 2 to the first. Yeah. And then 2 squared. Do you see like the multiplication pattern here? Times 2 times 2 times 2. Right. So for negative 2.25, you go to the left to negative 2, and you're just going to go like barely above the line, like as much as you can not go up the line, but still have the line. There. And then for negative 1, 0.5, you're going to go like up halfway, a little bit more. 0, 1, you're just going up, straight up to the 1. 1, 2, right there, and then 2, 4. So I'm going to show you how to connect these dots, like what this is going to look like every time. So this one's going to just kind of keep getting closer and closer to that x-axis. So it kind of goes right on top of it, and then it kind of like swoops up and like increases really fast. And you'll have arrows on both ends. So that's going to be the shape every time that you have the x as the exponent. It might like move around a little bit, but it'll be that same shape. Okay? Any questions on that? Cool. All right, moving on to the next part where you're just sketching graphs. This is probably something that you're either doing or will be doing very shortly in physics, where you're just kind of like sketching out a shape of a graph. So up there, main like bullet points to keep in mind. The main one that I need you guys to like beat into yourselves is that first one, label both axes, because a lot of people miss points on the quiz and test for not labeling, and those are silly points to miss. Okay. And then these are kind of easier just to do. Let's just do the first example. The water level in the bathtub, as you draw the bath, take the bath, then unplug the drain. So what are we measuring here? Yes, but be more specific. Huh? The water level. Yep, so we're measuring the water level over what? It's pretty much going to be time always. Like time is just going to kind of be passing, and then you're measuring something as time's passing. The time might change a little bit depending on the problem, but you'll kind of be able to spot when it's changing, okay? And you're kind of just sketching out what's happening here. So first you're drawing the bath. So what's going to happen to the water level? Yep, it's going to go up, right? Until it gets full. Then you're going to be taking the bath. What's going to happen to the water level? Nothing. It stays the same, right? So time is still going to be passing, but nothing's going to be like changing with the water level. So it's just going to be a horizontal line. And then the last thing that's happening is you're unplugging the drain. So what's going to happen to the water level? Go down, yeah. So as long as you have that general shape, you're good, okay? All right. B, your distance from home as you leave school, walk halfway home, go back because you left your phone in your locker, and then walk all the way home. So what am I measuring? Distance, be a little more specific. Like distance from where? Like distance from what? What does it say? What are you measuring? Your distance from home. Yep, distance from home. Because that's going to determine like where we start on the graph. If we're going to be far away from home, or if we're going to be not. And then the bottom is we're just going to keep time. So if I'm measuring my distance away from home and I'm at school, am I going to be the furthest from home or the closest to home? If I'm at school, am I going to be the highest for the furthest from home, or am I going to be closest to home? Furthest. So I'm going to start up high. Okay. So my distance is going to be the biggest. That's going to be from home. So I'm leaving school and walking halfway home. So we're going to walk about halfway down. Then you have to turn around and go back because you left your phone in your locker. So you're going to switch again and go back to the same distance you were before at the school. And then you're going to walk all the way home. So what's that going to look like?
Just go straight down.
Yep, all the way down to there.
Would it care if it went straight down?
Yeah, because that's basically like teleportation. Because like you're not allowing for time to pass. Does that make sense?
Yeah.
Okay. All right, you guys try these couple. All right, so this next one, the temperature in the oven as you preheat it, bake a cake, and then turn it off. So what am I measuring?
The
Temperature. And what's the bottom of me? Time. Okay, so first I am preheating the oven, so what's going to happen to the temperature? It's going to go up. Then I'm baking the cake, so what's going to happen?
temperature. Just go straight down.
Yep, stays constant. And then I'm going to turn off the oven. Go down, yep. Good. Make sense? Cool. And then the last one, your height as you age from infancy to 40 years old. On this one's a little different. So what am I measuring?
Right.
You're measuring your height, right? And then what would you label the bottom as? So any one of those, I would just do like your age. And this one's kind of hard to color coordinate because it's not like a specific event's happening. It's just kind of like a process. So I'm not going to. So whenever you are getting taller, are you growing at a constant rate always? No, right? So you kind of go through a growth spurt and then you just stay the same, right? And then spurt, stay the same. So I'm going to draw this as kind of constantly growing until you get to a certain point, and then you kind of level off, and then you're going to jump up. Then you're going to stay the same for a while, jump up, stay the same for a while, and then you kind of just stay the same forever until you get super old, and then you shrink. Yeah.
So you're just like on the brain.
Yeah, that's fine. Yeah.
You can shrink.
As long as you have horizontal lines in there, like showing like when it's constant, then you're, yeah, you shrink. It's real life. All right, do you have any questions on this? Cool. All right, next thing is we're going to go through and just talk about some things I need you to pay attention to when you're making a graph because they drive me crazy. Okay? So here's your checklist that I need you to be aware of. All right. So the first thing is that your scales are constant and they're also appropriate for the data. So what I mean by that is starting with 0, this needs to stay the same. So that's plus 2, and it continues like that, never stops, okay? The y-axis doesn't have to be going by the same amount that the x-axis is going by. They just have to be constant within their own, okay? But this one also happens to be going plus 2, but it doesn't have to be. It just has to be constant. Okay? And then appropriate for the data, meaning like you're using a good space of your graph. You're not using negatives for time, stuff like that. Okay? Next checklist thing. The corner must be 0. And that is your first values. You need to start seeing this as your first value, not the first number that you put on your axis. Okay? It has to start with 0. All right, next, both of your axes need to be labeled. Those are dumb points to miss. And then the last thing is that you know when to use or not to use the line at the end. So know when to use or when not to use an arrow. In this case, we would use an arrow because time's going to keep going forever. The temperature's going to just kind of keep rising. So there's values that we're not able to put on our graph. That's why we need the arrow. Okay, so we're going to go through these graphs and talk about what's wrong with them. Okay? You're kind of viewing these as like a teacher right now. I'm like trying to take off points. All right? So here's the table of values that goes along with all of these graphs. And so we're going to focus on this first one first. So why would you take off points on that graph?
There's no label.
No labels. Yep. All right, let's go to this one now. Huh?
They're not constant.
So they're constant. They're just like they're it's all 0, 1, 2, 3, 4, right? But like they all come together. Do you guys see that? Like the scale should be spread out more to like utilize the graph. So all right, this one in the corner.
It's not constant.
Which one?
Well, it goes to 17 and it skips 16. Like,
So could they be going up by 3s?
oh,
But it's 0 to 5.
Exactly. So 0 is your first number. You guys need to start seeing 0 as your first value, not whatever comes next as your first value. You cannot start the pattern from this number. You have to start from 0. So if you want to go 0, 5, you have to go 10, 15, 20. That's where it starts. Okay? So here, that's plus 5, and that's plus 3. Does that make sense? And I see that one a lot because people, I feel like, just take whatever the y numbers are and just put them on there. Just don't do that, okay? And then this one is one that like drives me up a wall that like everybody does, and it's an issue.
There's no 0.
Yeah, there's no 0, and then once you add the 0 in, it kind of becomes a little bit more obvious too what else is wrong.
the 1 is too spaced out.
No, that's fine. They all have 2 spaces between them, right? Oh.
The computer or is the line just one on the page?
There's 3, yeah. There's 3 boxes between each, right?
Is it the computer or is the line just not on the box? It's just the computer.
No, it's not on the dots, but it doesn't have to be. Yeah. Do you mean you said the line's not on the dots? Do you mean the dots aren't on the the corners? Like they're like randomly on the lines plotted?
No, like the line's like not perfectly on the dots.
Oh, yeah, maybe, yeah. Okay, so let's look at my scale real quick, guys. My corner is 0, right? That's my first number. So if my next line is 3, I'm making a decision right then that 1 box is worth 3, okay? That's my scale already set. So now I can't all of a sudden just decide to start skipping because then now you're saying 2 boxes are worth 3 and that's not the case, okay? So then this one, if that's 0, that's 3, then this would have to be 6. This would have to be 9. You'd have to continue going by 3 with every single box, okay? If you want to skip, that's fine, but you have to start the skip from 0. You have to go 0, skip the first one, and start writing on the second one. Make sense? Yes? Okay. Okay, so that one, the scale's unconstant. And that has to do with skipping. It's like doing every other. Okay. All right, just a couple of test prep questions that are quick. A water tank has 5 gallons of water and a tap is filling the water tank at the rate of 0.5 gallons each minute. How much water will be available in the tank at 3 minutes? Plot a line graph to show your answer. So how many gallons am I starting with? 5. Yep, so at 0, you're already starting with 5. And then it says so 0.5 gallons each minute. All right, so if I go over to 1 minute, then I should have gone up half a gallon. So where would I be? Yeah, 5.5. And then what? Yeah, then I'd be up 6. And then after 2, how many? 2 would be what? 6, yep. And then 3? Yeah. Okay. So, and then it asks how much water will be available in the tank at 3 minutes. So what would that be? Yeah. Does that make sense? Yeah? Okay. All right, and then number 13, the graph of the equation y minus 3x equals negative 9 is shown below. Select 3 points from the drop-down menus that show the solution to the graph. So this one's a little bit weird because the formatting of it was these were 3 different drop-down options that you could choose from. So you're picking basically 1 out of each of these 3 points to work, okay? So there's 2 ways that you can tell if something's a solution. 1, if you put it on the graph, it should be on the line. Then it's a solution if it's on the line, okay? Or if you can't do that for whatever reason or it's not an option, you also can take the x and the y, plug in the x and see if you get the y. And then that tells you that's the solution, okay? So let's kind of start with this first one. So we have 2, 3, 3, 0, and 9, 0. So let's try to see where those fall on the graph. So 2, 3 is going to be 2, and then right here. Does that work on the line? No. Okay, the next one's 3, 0. Does that one work? Yeah, let's just verify that the other one doesn't work. 9, 0. So it's going to be all the way over here. So that obviously doesn't work. So it's going to be the 3, 0. All right, and then with your next little group of 3, you have 1, negative 4. Like here, here. Is that on there? Not quite, yeah. 0, 0. 0, negative 9. Yeah. All right, then the last grouping, 12, 27, negative 4, 3, negative 6, 27. So we can try the negative 4, 3, but the other ones we can't. So negative 4, 3, let's try. Negative 4, 3. That one gonna work? No. So now, what I would typically do is I would take the function. So we have y minus 3x equals negative 9. Pick one of them, plug it in. So I'll just do the top one, the 12, 27. So I'll plug in 12 for the x. And then let's solve for y and see if we get 27 as our answer. So it's negative 3 times 12. Negative 36. So we have y minus 36 equals negative 9. And how would I solve that? Yeah. Y equals was negative 9 plus 36. Which is what they got for y. So that one's going to be the right answer. Okay, any questions on that? So I think over here is just put the numbers. So it's like 2, 3. For us. All right, there's the lessons. I think the last check's pretty much already completely on there for you on your paper. So for the first one, you're just making a table, plugging them and plotting points. For number 2, you're putting like letters that go with those words from here. Are you guys ready for answers? Not yet? Okay. Otherwise, you guys have like 10 minutes for homework, so maybe you want to. I guys, I'm gonna put the answers. Oh my gosh. Okay. Insane. All right. Rising slowly, constant, falling quickly. So what do you guys get for rising slowly? So that one's gonna be B. And then constant, C, and then falling quickly. Yep. Right. Any questions on any of this? So I'd work on homework. Probably honestly could get a good chunk of it done. Good.